Now we are going to talk about the types of velocity. We have two types of velocity: uniform velocity or variable velocity, or constant velocity and non-uniform velocity. So the two types are opposite to each other: uniform and non-uniform, or constant and variable velocities. Okay, the first one, if we looked at this example, we have a body started motion from rest. At rest, the distance equals 0 and time 0. After 1 second, it covered 10 meters. After 2 seconds, it covered 20 meters. After 3 seconds, it covered 30 meters. After 4 seconds, it covered 40 meters. So, in the uniform velocity, the body covers equal distances at equal periods of time. Equal distances or displacements at equal periods of time. And in this case, the magnitude and direction of velocity are constant. This is mean it moves in a straight line with constant velocity. That's why it didn't change. So body moves in a straight line. Okay, but the variable velocity and at rest, no displacement and no time, they are 0. After 1 second, it covers 1 meter. After 2 seconds, it covers 2 meters. After 3 seconds, it covers 4 meters. After 4 seconds, it covers 8 meters. So, in this case, we can represent or draw a graph for each type of velocity. On distance time graph, we will find that the uniform velocity represented by straight line passing by the point of origin. Okay, this point of origin. But in case of variable velocity, we find that it is curved line on distance time graph. Okay, to calculate the average speed or the speed in certain moment in the variable velocity, we have something called instantaneous velocity. In this case, we can't calculate the slope of the curved line, so we draw a tangent line of this curved graph. Then we calculate its slope to find out the velocity in this instant. So the instantaneous velocity is the velocity in a certain instant or in a given moment or something. Okay, great. For example, we have here a moving body. It appears from the curved line that it moves with non-uniform velocity. If we draw a tangent line at point P, then we calculate the slope. The slope means difference of this axis, displacement axis, over distance of time axis. We are naming the time axis t and displacement x. So delta x over delta t will give you the velocity, the magnitude of velocity. Okay, then we draw another tangent at point Q. It gives us a different velocity. We calculate with the same rule, delta x over delta t. Okay, we'll find that v, or the velocity at P, is different from velocity at Q. And this is logic because the body moves with variable velocity, so the velocity changes from time to time. The body speeding up or slowing down or whatever. It's not easy to move with uniform velocity all the time. If the car moving on the road, we have road conditions and we have traffic that make the drivers had to change their velocity from time to time by slowing down or speeding up. Okay, in this case we can calculate the average velocity of motion, which calculated by total displacement from a starting point to the end point over the total time. Okay, in order to calculate that, we can determine the slope of straight line joining starting point and ending point. Now we have the curved path on the graph. We draw a line at starting point intersect with the curved line of graph and intersect by the ending point, and we find the slope of this line. In this case we're going to find the average velocity. So the difference between an instantaneous velocity and average velocity, the average velocity is the median velocity during motion, during the whole motion, but the instantaneous velocity is the velocity of the body at certain moment. Okay, great. So what's meant by instantaneous velocity of car 5 meters per second? This means in a specific time or a specific moment the velocity of car is 5 meters per second, but the average velocity of the train equal 30 meters per second. This means the total distance or total displacement divided by total time equals 30 meters per second. When we say that a body covers a displacement 20 meters in 4 seconds, this means its velocity equals 20 over 4, which equals 5 meters per second.